The first thing that we need to do is to determine how many arbitrary constants do we have in our problem. In this case, we only have one, which is b, which indicates that we only have to get the first derivative of this function and then simplify it. But first, we will isolate the arbitrary constant. To do that, we will multiply both sides by arctan. And there, we will have arctan y is equal to, so cancel. We will only have bx here. But since b is not completely isolated because of the presence of x, we will divide both sides by x. And cancel, cancel. We will have arctan y over by x is equal to b. And after that, we will get the first derivative. We will proceed to getting the first derivative of the function. Denominator multiplied by the derivative of numerator minus numerator. So, and the derivative of the denominator, which is 1. So, since it's only 1, hindi na natin siya ilalagay dito. Because ganun pa rin naman. And then, all over by the square of the denominator, which is x squared, is equal to, since b is constant, its derivative is 0. To cancel this x squared on the denominator, we will multiply equation by x squared. So, cancel, cancel. You will have here x. And isulat na natin yung derivative ng arctan. So, the formula for the derivative of arctan is of arctan u is equal to the derivative of u over by 1 plus the square of u. So, here, the derivative of u, so u is equal to y, so y prime over by 1 plus the square of the u, which is y squared, and then minus arctan y is equal to 0. And then, to simplify this more, we will multiply the equation again to 1 plus y squared. So, here, so x times y prime. So, cancel na to. Minus, so 1 plus y squared times our arctan y. So, we will have 1 plus y squared, close parenthesis, and open parenthesis, arctan y, close parenthesis, is equal to 0. So, here is our answer for our first problem. X, y prime minus parenthesis 1 plus y squared, close parenthesis, open parenthesis, arctan y, close parenthesis, is equal to 0.
Ang gagawin natin, i-eliminate natin ang arbitrary constants. In this equation, we have 2, which are a and b. In able to do so, we need to find the number of arbitrary constants because it will tell us on how many times we will perform differentiation for that equation. First, let's find the first derivative. We have a as constant times the derivative of ln of y is y prime over y equals b as constant times the derivative of e raised to x squared is e raised to x squared times the derivative of x squared, which is 2x. By simplifying, now let's label this new equation as equation 1. Now let's proceed to finding the second derivative. So we have a as constant. The derivative of this quantity, we can use quotient rule of differentiation, which is we will get y times y double prime minus y prime times y prime all over y squared equals 2b as pure constant and the derivative of these. By inspecting, we can perform here the multiplication rule of differentiation, which will give us x times e raised to x squared times 2x plus e raised to x squared times 1. By simplifying, in this quantity, as we can see, we can factor e raised to x squared. So, leaving us 2x squared plus 1 on the quantity. Let's multiply this denominator to the right side. Now, let's label this equation as number 2. Now, let's try to isolate a by multiplying the whole equation to 1 over y double prime minus y prime squared. Now we have the value, we have a function. Now let's try to substitute this value to the equation 1, giving us 2b y squared e raised to x squared times 2x squared plus 1 all over y double prime minus y prime squared times y prime over y equals 2bx e raised to x squared. On the left side, we can cancel 1y to the numerator and denominator. And also, by inspecting the whole equation, we can cancel out similar multipliers, which are 2b and e raised to x squared. Leaving us this equation now. We have y prime times 2x squared plus 1 all over y double prime minus y prime squared equals x. Now let us multiply this whole denominator to the right side. And now we have the final equation.
So again, the first thing that we need to do is determine kung ilang arbitrary constant ang meron tayo sa problem. Here we have c sub 1 and c sub 2. So we have two arbitrary constant which indicate na hanggang second derivative ang gagawin natin. So getting the first derivative of the function, we have y prime. So c sub 1, since it is constant, makakancel na siya, is equal to 0 lang naman siya. So here, we have c sub 2, e raised to 3x squared. Looking back, the formula for the derivative of exponential function, derivative of e raised to u, is only equal to e raised to u, so the derivative of u, the derivative of the exponent of e. So here, 3x squared, the derivative of that is equal to 6, 3 times 2, so 6, and x squared, x raised to 2 minus 1, so x na lang siya, and copy the c sub 2, and copy the e raised to 3x squared. From there, we will get our second derivative. So again, 3 times 2, 6, and x raised to 2 minus 1 is x, so we have 6x multiply dito. We will have 36x squared. So 6x times 6x. C2, copy lang, e raised to 3x squared. So after that, we will label this as equation 1, equation 2, and equation 3. So in order to eliminate this arbitrary constant here, we will use elimination method. By that, we will get the difference between the equation 2 and the equation 3. So, ayan, difference. So, para makancel natin tong dalawang equation, we have to multiply 6x to equation 2. para mag-equal siya sa 36x squared. So here, 6x y prime is equal to 36x squared c sub 2 e raised to 3x squared. Copy lang natin yung equation 3. Ayan. So, makakancel na to and eto. So, we will have 6x y prime minus y double prime is equal to, so cancel, 0 na yan. And that's our final answer. Since wala nang arbitrary constant na makikita sa function. So that's our final answer for problem number 3.
And we have here two arbitrary constants, which is c sub 1 and c sub 2, and we need to do until second derivative to find s double prime, in which s prime is equals to ds over dt. So the first step here is to find the first derivative. So derivative of s is simply s prime. Derivative of c sub 1 e raised to t is c sub 1 e raised to t. And in this part, we need to use the product rule, in which our first term here is c sub 2 t and the second term is e raised to t. So copy the first term, c sub 2 t, and derivative of e raised to t is e raised to t, plus derivative of this term c sub 2 t, and copy the second term, which is this. So this is our second equation, and this will be our first equation. And the next step is to find the second derivative. So this will be s double prime. Derivative of this term is c sub 1 e raised to t, plus derivative of this equal to this, plus the derivative of the last term of our second equation is equal to this. And we can see that we can add the last two terms of this equation. So, and this is our third equation. So we can use equation 1 and equation 2 to eliminate c sub 1. We can subtract equation 2 and equation 1. We can see that we can cancel these two and also these two terms. So it is equal to c sub 2e raised to t. We can see that we can substitute the value here to our equation 1, and we can substitute it here. So we can distribute the t in this term, and we can get the value of c sub 1 e raised to t here. So c sub 1 e raised to t is equal to s minus ts prime plus ts. And now we have the value of c sub 1 e raised to t and c sub 2 e raised to t, and we need to substitute it to our equation 3. So we need to distribute the t here and the 2 here. So here we can add similar term here. So negative ts prime and positive ts prime, it will cancel each other. And also the ts and the negative ts. And we have here s minus 2s. So we have here negative s and plus 2s prime. So we can equate it to 0. We have here our final answer, which is s double prime minus 2s prime plus s is equals to 0. That's our final answer.
t equals 2xy squared over x derivative of y sine y minus xy, derivative of y, cosine y, minus y sine y. D 2xy squared is equals to 2x times 2y, derivative of y, plus y squared. For xy, derivative of y plus 2y squared. Dxy, x derivative of y sine y is equals to x derivative of y times cosine y derivative of y plus sine y times x second derivative of y plus derivative of y equals to x times derivative of y squared cosine y plus sine y x second derivative of y plus derivative of y sine y. D negative xy derivative of y cosine y is equals to negative xy times x derivative of y times negative sine y derivative of y plus cosine y second derivative of y plus derivative of y cosine y times negative x second derivative of y plus y negative 1 is equals to positive xy times derivative of y squared sine y minus xy second derivative of y cosine y minus x times derivative of y squared cosine y minus y derivative of y cosine y. D negative y sine y is equals to negative y cosine y derivative of y plus sine y negative derivative of y. Negative y cosine y derivative of y minus derivative of y sine y. 0 is equals to x derivative of y sine y minus xy derivative of y cosine y minus y sine y times 4xy derivative of y plus 2y squared minus 2xy squared times x times derivative of y squared cosine y plus sine y x second derivative of y plus derivative of y sine y plus xy times derivative of y squared. Sine y minus x y second derivative of y cosine y minus x times derivative of y squared cosine y minus y derivative of y cosine y minus y cosine y derivative of y minus derivative of y sine y over v squared. 0 is equals to 4x squared y times derivative of y squared sine y plus 2xy squared derivative of y sine y minus 4x squared y squared times derivative of y squared cosine y minus 2xy cubed y derivative cosine y minus 4xy squared derivative of y sine y minus 2y cubed sine y minus 2x squared y squared times derivative of y squared cosine y minus 2x squared y squared sine y second derivative of y minus 2xy squared sine y derivative of y minus 2x squared y cubed times derivative of y squared sine y plus 2x squared y squared second derivative of y cosine y plus 2x squared y squared derivative of y squared cosine y plus 4xy cubed derivative of y cosine y plus 2xy squared derivative of y sine y. By simplifying the last equation, the final answer is 0 is equals to 2x squared y times derivative of y squared sine y minus 2x squared y squared times derivative of y cosine y minus xy squared derivative of y sine y plus xy cubed derivative of y cosine y minus y cubed sine y minus x squared y squared sine y second derivative of y minus x squared y cubed times derivative of y squared sine y plus x squared y squared second derivative of y cosine y.
Two arbitrary constant, a and b. So we need to have second derivative of the given equation. So first we must isolate a by transposing it to the other side. So we got y squared minus b second x is equal to ax squared. And then we can divide all the terms with x squared. So we can cancel this. So we got y squared over x squared minus b second x is equal over x squared is equal to a. quotient rule of this term, y squared over x squared. So we got 2x squared y prime minus 2x y squared, and then x over x raised to 4, then constant p, and then quotient rule of second x over x squared. We got x squared second x tan x minus 2x second x over x raised to 4. Then the derivative of a, which is constant, is 0. So we can multiply this to x raised to 4 to cancel this out. So we got, and we can also factor x in this expression. So we got x 2xy prime minus 2y squared is equal to b x squared second x tangent x minus 2x second x. And then you can multiply this whole expression to the other side, also to this side, to cancel this out. And we can also factor out x with this equation. So we have here in this side x is equal to x second x tangent x minus 2 second x. So we can cancel this. So we have p is equal to 2x y double prime y prime minus 2y squared over x second x tangent x minus 2 second x. Here we can factor out 2, so it becomes 2 xy prime minus y squared, to become more simpler, taking this derivative. So we take the derivative of b quantity x second squared tan x minus 2 second x is equal to 2 quantity xy prime minus y squared. So for the second derivative of that, first is constant, and then product rule of second x tan x. So we had p is equal to x second squared x plus x second x tan squared x plus second x tan x, and then the derivative of second x, which is second tan x, minus 2 second x tangent x is equal to the derivative of 2xy prime minus y squared is 2. It's constant, then product rule. So we have xy y double prime plus x y prime squared plus y prime, then the derivative of negative 2y squared, which is negative 2y y prime. And then to simplify, this second squared have an identity, which is 1 plus tangent squared x. So we transpose this expression to this expression. So we can have b quantity x second x plus x second x tangent squared x plus x second x tangent squared x plus second x tangent x minus 2 second x tangent x. Then copy this is equal to to quantity xyy double prime plus xy prime squared plus yy prime minus 2yy prime. And then we can combine terms. This term and this term and also this term and this term. So we can get b is equal to x second x plus 2x second x tangent squared x minus second x tangent x. Then copy this again. And then we substitute the value of b to this expression. So the value of b is this one. Is this one. So we can substitute it to have 2 xyy. And factor it out. xyy prime minus y squared over x second x tangent x minus 2 second x. So we have second x quantity x plus 2 x tangent squared x minus tangent x. Here we can cancel this second, this, and this. You can factor that out. So you have 2 xyy prime minus y squared over x tangent x minus 2 times x plus 2x tangent squared x minus tangent x, and then equal to 2 xyy double prime plus x y prime squared plus y prime minus 2y y prime. And you can have this as your final answer.
So the arbitrary constants are a and b. So the first derivative is 1 is equal to a times 2y y prime minus y prime over y. So we need to multiply both sides by y, so we can remove the denominator y. So transpose the negative y prime and simplify the equation. So divide both sides by y squared and y prime. So we can remove the constant of 2a. So the answer will be, so this is our first derivative. So now we will do the second derivative. We will use this equation to get our second derivative. So the second derivative will be the second derivative will be y squared y prime times y prime plus y double prime minus y plus y prime times y squared y double prime plus y prime times 2y y prime. So simplify this equation. So this is the simplified form of the equation, but there is still another operation which is the minus sign, or the negative one. So we'll distribute this to this equation. So the next one is we will combine like terms, which is y squared y prime squared, and the negative 2y squared y prime times y prime squared, and y squared y prime and y double prime, and y squared y prime negative y squared y prime y double prime. So the answer will be negative y squared times y prime squared minus y cubed y double prime minus 2x times y squared cubed. So this will be the final answer. So starting from the x-axis, the straight lines are to the right. So we're going to be using the slope-intercept form, which is the y is equal to mx plus b. So first we're going to get the value of m. We're going to use the slope of the perpendicular, which is m is equal to negative 1 over m. So the first m is the line AB, and the second m is the line CD. Substitute the value of m to 55 degrees. Tan 55 degrees is equal to negative 1 over tan 55 degrees. So the answer will be m is equal to negative cotangent 55 degrees. So we have the value of m, the arbitrary constant 1, which is the b. So y is equal to, substitute the value of n, negative cotangent 55 degrees plus b. So to remove the arbitrary constant, we need to get the derivative. So y prime is equal to negative cotangent 55 degrees. So this is the final answer.
So if we're going to plot the graph, is we're going to center and all the lines. So if we're going to observe the line, the slope is equal to the derivative of the equation of the unit circle. So derivative gives us the slope of the tangent line at a common point. So from the equation of the line, y is equal to mx plus b. The derivative of y prime is equal to m. So in the equation of the circle, which is h is equal to 1 and k is equal to 1, we got an equation based on the equation of the circle, that is x minus 1 squared plus y minus 1 squared is equal to 1 squared. So taking the derivative of this, we got 2 x minus 2 plus 2y prime minus 2y prime is equal to 0. Simplifying, we got x minus 1 plus y double prime minus y prime is equal to 0.
X minus h squared plus y minus k squared is equals to r squared. R is equals to h and k is equals to 0. Therefore, x minus h squared plus y squared is equals to h squared. X squared minus 2xh plus h squared plus y squared is equals to h squared. X squared plus y squared is equals to 2xh and AC is 1. The first derivative is 2x plus 2y, y derivative equals to 2h, and x plus y derivative is equals to h. X squared plus y squared is equals to 2x times x plus y and y derivative. X squared plus y squared is equals to 2x squared plus 2xy, y derivative. Y squared is equals to x squared plus 2xy, y derivative.
Let's obtain the differential equation of the family of curves. First, let's sketch and suppose this is x and y axis, and suppose this is the graph of the line y equals to x. Now the condition tells us that the center of all circles should be lying on the line y equals to x, so it should look like this. Now, as we all know, the standard equation for a circle is x minus h squared plus y minus k squared equals r squared, whereas the h and k serves as the coordinates for the center and the r is the radius. Now, by inspecting this sketch, we have y equals 2x for the equation of the line, and we can observe that all center of all circles are lying on the line. Therefore, we can also say that k equals 2h. Now that we have come up with the value for k, let's try to substitute this to the equation of the circle. Now, by counting the arbitrary constants, we get 2, which means that we should perform differentiation 2 times for this equation. So let's find the first derivative. 2 times x minus h, the derivative of h is 1, and the derivative of h is 0, plus 2 times y minus 2h, the derivative of y is y prime, and the derivative of 2h is 0. We are getting the derivative with respect to x, by the way. The derivative of r squared is 0 because it is pure constant. Now let's try to multiply the whole equation by 1/2 so that we can cancel out the 2's, giving us only x minus h plus y minus 2h y prime equals 0. Now let's label this new equation as equation 1. So before I proceed on getting the next derivative, first I will try to arrange this equation by isolating the h. By doing that, let's expand the equation first, and then let's leave the terms containing h on the left side and transpose all the remaining terms which has no h. Let's multiply this whole equation by -1. Now let's factor h here. Then let's multiply the whole equation by 1 over 1 plus 2y prime. Now let's get the derivative. The derivative of h is 0. And here we can use the division rule for differentiation. Let the numerator be the u and the denominator be the v. We have v times the derivative of u, which is 1, plus y double prime plus y prime square minus u times the derivative of v, which is 0, plus 2y double prime, all over v square. Now let's multiply the whole equation by 1 plus 2y prime square, giving us 0 equals. Now let's try to expand these two quantities, giving us 1 plus y double prime plus y prime square plus 2y prime plus 2y prime y double prime plus 2y prime raised to 3 minus, let's expand these two quantities as well, and let's apply the negative sign already, giving us negative 2xy double prime minus 2y y prime y double prime. As you can see, this term and this term will be equivalent to 0. So let us cancel them out, giving us 0 equals 1 plus y double prime plus y prime square plus 2y prime plus 2y prime raised to 3 minus 2x y double prime. Now this form can already serve as the final equation, but you may want to factor the similarities of each terms if you'd like.
B. We need to obtain the differential equation that describes the family of curves. So this is what it looks like. I have circles here with same radius, and all of them are passing through the origin. And since we're dealing with circle, our equation to be used is quantity x minus h squared plus quantity y minus k squared is equals to r squared. So since r is fixed, so nothing will be changed here, but arbitrary constants will become h and k only since r is fixed. So we need to do until second derivative and to find y double prime. Our working equation here is, so this is our working equation there. That will become the first equation. And the next step here is to find the first derivative. So in this part, we need to use the chain rule. So 2 times x minus h, and derivative of this is only 1. So for that, 2 times y minus k minus 1 with exponent 1, then derivative of this is y prime is equals to derivative of this is a constant but not an arbitrary constant, so this is 0. So we can actually multiply it by 1/2. 0. This is our equation 2. Next step is to get the second derivative. So derivative of x is just 1, derivative of h is 0. And in this part, we need to use product rule. Copy the first term, y minus k. Derivative of y prime is y double prime. Plus, copy the second term times derivative of this is just y prime is equals to 0. We can simplify it as, and we can actually find y minus k here. So y minus k is equals to, move this one in the right side, negative 1, also this term, and dividing it to this term, y double prime. So this is our equation 3. And as you can see, we can substitute equation 3 to equation 2 to find x minus h. So we can multiply this y prime, distribute it in the numerator, and move it to the right side. So x minus h is equals to y prime plus y prime cubed and y double prime. So this is our equation 4. So as you can see, we can substitute equation 4 and equation 3 to equation 1 to eliminate all of the arbitrary constant. So this will become, we can distribute the exponent to the numerator and the denominator. So this will become, and we can multiply the whole equation to the y double prime squared. And also we can expand this numerator also this. So this will become y prime squared plus 2 times y prime raised to 4 plus y prime raised to 6. Then this is 1 plus 2y prime squared plus y prime raised to 4 is equals to r squared times y double prime is r squared y double prime squared. So we can add all terms which is similar. So y prime squared, and this is 2y prime. So this will become 3y prime squared. Also this term and also this term. That's 3y prime raised to 4. And copy this one, y prime raised to 6 is equals to r squared y double prime squared. So this is our final answer.
And here's our illustration. This is the x-axis, this is the y-axis. All of our parabolas concaves downward as stated on the statement. And all of their vertex lies on the line y is equal to 4. And the distance between the focus and the vertex of all of our parabolas are fixed. Then we can say that A is fixed. So it is not an arbitrary constant. And then we can also notice that there is no vertical shift because the parabolas are all lies on the y is equal to 4. So we can say that y is equal to k, and so we can use this to our equation of parabola. So the equation of parabola is the general equation for parabola is x minus h squared positive negative 4a parenthesis y minus k. But since all of our parabolas are concaving downward, we will use the negative sign to indicate that our parabolas are concaving downward. And then we will identify how many arbitrary constants do we have. A is fixed, so it is not an arbitrary constant, and our y or k is also not an arbitrary constant because it is equal to 4. So we can see that there is no fixed horizontal position of our parabola. So there is one arbitrary constant which is equal to x, or we can also label it as h. And then we will now proceed to the computation. Substitute our k to the equation. Then we will simplify, distributing negative 4a to y and negative 4. Then we will label this as equation 1 and this as equation 2. And then, since we only have one arbitrary constant, we will only get the first derivative of this function. Getting the first derivative. So the derivative of x minus h raised to 2 is only 2. So ibababa to 2x minus h. And the exponent will be subtracted by 1. Then is equal to the derivative of negative 4a y is equal to negative 4a y prime. And since this 16 and a is constant, their derivative is 0. So hindi na natin sila ilalagay. Then we can simplify this equation by multiplying 1/2 on both sides. We can substitute this to equation 2. Since x minus h is equal to negative 2ay primes, our equation number 2, we also have x minus h here. So we can substitute this term para ma-eliminate natin yung arbitrary constant, which is h. And we can still simplify this. Before we simplify, let's just perform this squared first. So we will have positive 4 and a squared, and then y prime squared is equal to negative 4ay plus 16a. And then we will multiply 1 over by 4a so that we can simplify this 4 and 16, and we can simplify the a's. And then we can transpose this to the other side para maging positive siya. Y is equal to, and then we can transpose this to the other side. So magiging negative na siya. Negative a y prime raised to 2 and plus 4. So this is our final answer. Y is equal to negative a y prime squared plus 4.
Before we sketch, let's identify the vertex and the point. It tells us that the vertex lies on x-axis, which means that it has no y component, so that the k should be 0, and the point is 1, 1. Now for this problem, I can think of two different cases, whereas case 1 would give us a sketch whereas the parabolas are opening upward and all of them are passing through the point 1, 1 and their vertex lies on the x-axis. The second case that I can think of is parabolas opening sidewards, either left or right, as long as these parabolas contain a point 1, 1. Also, their vertex lies on the x-axis. First, let's try to work on case 1. The set of parabolas here only opens upward, so the equation should be x minus h squared equals positive 4a times y minus k. And since the vertex is h0, this quantity only leaves us y. And since it passes through point 1 and 1, let's substitute values for x as 1 and y as 1. Now let's isolate a. Now let's substitute this onto the equation. Now for this equation, we only have one arbitrary constant, so let's find the derivative. The derivative of this is 1 minus h squared, and the derivative of y is y prime. By inspecting this equation, I doubt that you can factor out h. Therefore, we cannot eliminate the constant. H is not factorable, so it cannot be eliminated in this way. So if we cannot eliminate the constant, therefore this convention, whereas the parabolas are opening upwards, will not be useful on giving us a differential equation. So let's try case number 2. By inspecting, we have parabolas opening sidewards, so it should give us an equation of y minus k squared equals positive negative 4a quantity x minus h. And since the vertex is h0, the k is 0, so it will only leave us y squared equals positive negative 4a times x minus h. And since we have 0.11, let's substitute these values to x and y. Again, let us try to isolate a, and then let's try to substitute the value of a here. We can cancel out positive negative 4, giving us y squared equals x minus h over 1 minus h. Now let's try to arrange this equation whereas h is isolated. Let's multiply this here and transpose this negative h here. Also y squared, let's transpose this to the right side and let's factor h here. Let's divide both sides by 1 minus y squared so that h equals x minus y squared over 1 minus y squared. Now it gives us with the new equation, whereas the number of arbitrary constant is 1, and that is h. So let's find the derivative. 0 equals, let the numerator be u and let the denominator be v. So v times the derivative of u minus u times the derivative of v all over v squared. Let's multiply this whole equation by 1 minus y squared quantity squared, giving us 0 equals. Now let's try to expand these two quantities, giving us 1 minus 2y prime minus y squared plus 2y cubed y prime minus, let's expand this. We have negative 2xy y prime plus 2y cubed y prime, and let's distribute this negative in this quantity. As you can see, these two terms equate to 0, so we can just cancel them out, giving us 0 equals 1 minus 2y prime minus y squared plus 2xy y prime. Now this form can already be our final equation, but if we want to factor out 2y prime in these two terms, then you may do so.